Okay, so this is the final video and a final example on implicit differentiation. For this video, we're going to look to take the second derivative. So we always start off by taking the first derivative. So we're going to take the derivative here of both sides, okay? And the derivative of y squared minus xy, and then we're going to take the derivative of 8, okay? So when I take the derivative of this, it's going to give me 2y, but then I'm going to take derivative of y with respect to x, so that's dy dx, minus the derivative of xy is going to be x, derivative of y is dy dx. Okay, plus y times the derivative of x, which is just 1. And the derivative of 8 we know is 0. Okay, so now we're going to try to isolate our dy dx here. So when I isolate dy dx, I'm going to be left with, let's just clean this up and distribute out first, and then I'll isolate it. So I've got 2y dy dx minus x dy dx minus y equals 0. Okay, so I'm going to pull out dy dx, and when I pull out dy dx, I'm left with 2y minus x equals, bring the y over to this side, so divide both sides by 2y minus x and divide by 2y minus x. So that gives me a first derivative of y over 2y subtract x. Okay, so we're halfway there. Now we need to find the second derivative. Okay, so we're going to use, to find the second derivative, we're going to use the first derivative. So we're going to start here, and notice the notation where you say d squared of y over dx squared. Okay, so d squared of y over dx squared is going to equal this. So now the quotient rule is going to be used. So I'm going to take 2y minus x squared. Then I'm going to take the denominator of 2y minus x times the derivative of y is dy dx. Okay, minus your numerator. Now the derivative of this, you have to be careful with your variables again. So the derivative of 2y is 2, but then you've got dy dx minus the derivative of x is just 1. Okay, so at this point, this is where it gets a little tricky because there's a lot of different directions on ways to go, but what I suggest you do at this point is substitute right in. Dy dx, we know what it is. We know that it's this value right here, this expression, so put it in right away. I wouldn't wait and simplify anything out because it just gets messier. So I would simplify things out and see what cancels. So I'm left with 2y minus x, and then I'm going to be substituting in y over 2y minus x. Okay, so minus y times 2, and then I'm going to be substituting this messy thing in of y over 2y minus x. Close the parentheses there. And then I've got a minus 1. Close that parenthesis, and this is all over 2y minus x all squared. Okay, so what happens here is this expression right here would cancel with this expression here. Okay, this does not cancel, however. So in the next step, I'm going to try to clean this up a little bit. So in the numerator, I'm going to end up with just a y. And over here, I'm going to end up with negative 2y squared over 2y minus x. Okay, and then I'm going to take a negative y and I'm going to distribute it out to here, so that makes it positive y all over the same denominator of 2y minus x all squared. Okay, so now if I simplify this, I'm left with 2y minus 2y squared over 2y minus x all over 2y minus x all squared. Okay, I do need to get a common denominator here. So to get a common denominator of 2y minus x, I'm going to pull out, let me keep it in black here. So I'm going to do a common denominator of 2y minus x. Okay, this expression right here is 2y, but I didn't have a 2y minus x over here, so I want to multiply it by 2y minus x. So this expression will just stay 2y, but has a common denominator now, minus 2y squared all over 2y minus x all squared. Okay, so at this point, now I'm going to multiply 2y times 2y. That's going to give me 4y squared minus 2yx minus 2y squared all over 2y minus x. Now I've got this fraction in the denominator, so I'm going to bring it up here and make it 1 over 2y minus x all squared. So the result here, 4y minus 2y, is going to end up giving me 2y squared. I have a minus 2yx over. This expression is now cubed. So I've got 2y minus x all cubed. That is the answer to the second derivative of this function right here would be your final answer.